Welcome homeowners and future electricians. I have some more videos on their homeowners electrical professor here. My name is Paul Esposti. I am your host. We're still talking about continuity and faults, the relationship between them. Now we're going to talk about the human body involved in a fault. When the human or an animal body, cat or dog, becomes part of an electrical circuit due to an electrical fault, current or amperage will flow through the body. The amount will depend on Ohm's law. Current is equal to voltage divided by resistance. The higher the voltage, the higher the current flow. The lower the resistance, the higher the current flow. Those of you who like to play around with math will notice that the relationship between current and voltage is proportional. As the voltage goes up, the current would go up. It's also inversely proportional to the resistance. The lower the resistance, the higher the current. The resistance of the human or animal body is higher than the resistance of copper wire. Therefore, when the body becomes part of an electrical circuit, the resistance will limit the current flow so that the current flow is not enough to trip the circuit breaker. This is when ground fault circuit interruption becomes important. I have videos on ground fault circuit interrupters that you can refer to. Resistance of the human body, the electrical resistance of the human body is depending on many different factors. Where the current flow enters and leaves the body, humidity, wetness of the skin, conditions of the skin, and more. Studies have shown that the resistance of the human body can vary from approximately 500 to 5,000 ohms. If electricity enters a finger and leaves this finger, that path is short. If it enters this hand, leaves on this hand, it's a longer path. Between here and the feet is an even longer path. That's why that resistance will vary from human to human. The conditions of your skin, wetness, that's why when we're around in kitchens, bathrooms, garages, concrete is conductive. Keep that in mind. That's why we have to have ground fault protection in these areas, okay? The most dangerous electrical shock for a human is through the human body. You have your heart here, which basically operates on electrical impulses that keep it beating. You don't want to go into cardiac arrest because of electrical shock. Remember, current is equal to the voltage divided by the resistance. If a human is part of a line to neutral ground fault, the current, if it's 120 volts divided by, say, this 500 ohms over here, there would be about 0.24 amps or 240 milliamps flowing through the body. If at the lower end or the higher end, at 5,000 ohms, 120 volts divided by 5,000, you'd have 0.024 amps, which is 24 milliamps. Now remember, under ground fault circuit protection, the GFIs that we use in residential applications are designed to trip at 5 milliamps, 0.005. As you can see, both of these numbers are more than enough to trip that ground fault circuit protector. The amount of amps is not enough to trip a 15 or 20 amp circuit breaker. That circuit breaker, it only knows that there's 0.24 amps going out. It doesn't know that whether it's going to charge your flashlight or whether it's going through the human body. It only knows that's not enough for me to trip because of an overload or a short circuit. And that is why ground fault circuit protection in humans is very important. Thank you.